Every once in a while, you might find yourself dropped into a project which is brownfield. It's something that's existed for ages, and you need to figure out what the problems are and how to solve them. Let's smash on that. Hi, everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, we're going to take a look at a tool that has been around for a lot of years, and I just never get around to using it. But I'm running into a need for it at the moment. So this tool is called NDepend, and it is basically like a query language that you can run on top of your code base. That'll give you a bunch of ideas about what your code is doing, how it's built, dependencies between different parts of the code base, and so forth. So what I have here is a large and old project. This is actually a thing called ADX Studio. It integrates with Dynamics CRM, and it's awful. But regardless, it was open sourced, and we've got all this code here. And as you can see, like it's pretty significant. There's quite a few projects here, and quite a lot of lines of code. So if you were to inherit a project like this, and your job was to make it better, to maintain it, your first step would have to be to figure out, like, where are the problems and where am I likely to see bugs? So hopefully you would have some sort of bug list, but if not, then you could fire up NDepend here. So I've just run this, and this is just in the stock configuration over the project, and it's gone and it's done a full analysis of the entire project. And built into this kind of daunting looking dashboard here are some ideas about what is wrong with the project. So you can see these graphs here don't have much on them, just a single point of data, because the idea with NDepend is that you run it with some frequency, maybe like once a week or once a month, or integrate it with your builds, and it will run its metrics again and see if things have gotten better or if they've gotten worse. So you can baseline your project and then put it into the build pipeline, and if things get worse, then you can fail the build and stop people from doing stuff. But right now we can take a look at a bunch of different sections here. So it gives you an idea of kind of how big the project is. So it's almost 900,000 IL instructions, which means like totally nothing to me. But it seems like a big number. But more interesting to me are things like there's 4,000 different types in this project. It's spread across 7 assemblies and 321 namespaces. There's 17,000 methods and 3,700 fields inside the application. So it's fairly significant. And over here we can see this thing called det, which is a calculation of how bad things are inside the application. Like if you were to fix everything so that all the rules passed, then it would take you 246 days to do that. But the annual interest on that is like it's going to cost you like 117 days a year, person days a year, to just to maintain this project, to fix stuff that's coming in. And these are obviously like wild estimates, but it gives you some metrics around it. So it gives you an idea of like, are things getting better or worse? I mean, to me, these are like those scales that you get that tell you your body fat. I mean, they're hopelessly inaccurate compared with a proper body fat test. But if you use it every day, like at least it's internally consistent, so you know if you're going up or you're going down. But let's take a look at some of the rules that we've got in here. So it's got a section here for like critical things that we've messed up, rules that are slightly less important that we've violated, and the things that are, they're okay. So let's take a look at these critical rules here. So we've got something here that says we should avoid methods with too many parameters, and there's 389 or so of those which are a problem. So we can drill into this here. We can see like where are these methods that are problematic, and how can we help solve them. So I'm just going to make this a little bit bigger. So a good indication is like how long it's going to take us to fix these. So there seems to be quite a few in here. It's going to take us 5 hours to fix the ones in here. So if we keep drilling into these things here, then it'll jump to that section inside of Visual Studio for you. And you can see that, yes, indeed, this method has 15 parameters to it, which is awful.
Well, it's still
But
only 2-digit number. It's not too bad.
yeah, I mean, there's at least 1, 2, 3, 4, 5, 6 that you have to provide values for, and there's a bunch of defaults for the rest. But this is an indication to me and also to NDepend that like this is a really complicated method, and there is something going on with it that it's worth exploring and refactoring. And so there's a lot of rules for different things in here. So you can see down here like a bunch of different rules that you have, even little things like trying to avoid naming clashes. There's a lot of places in this application where we have the same named object in a couple of different namespaces. We have hiding of base class methods. I was just talking with James about this morning, in fact. We drill into one of these here. You can see that whatever this method here is, it's got new on it. So that indicates that it's hiding the base class method. And the base class method is not marked as virtual, so you probably shouldn't be overriding it in this way. I never like to see this kind of like new indicator here.
Yeah, if it's not there, you get a compiler warning. Then people's solution to that is often put the new, but it might not be what you actually meant or intended to do.
Yeah. And so it has a web interface too. So if you were running this inside of your build engine, this is sort of like the result that you would get back out of it. And it has some cool sort of graphs in it too that gives you an idea of interdependencies between your code. So it's like a dependency graph here, so you can see kind of what depends on what. So you can see this site project up here depends on pretty much everything else in the entire universe. So it means that if you have something that has a lot of incoming arrows to it, it means that refactoring it is probably going to be quite difficult. So something like this up here, it's a little bit difficult to read. It is dev threads or something. So this has got a couple of different incoming arrows to it. So it means that if you've refactored it, you're probably going to have to walk back up this dependency and fix it in multiple other places to get it to work properly. A dependency matrix gives you an idea of kind of like what depends on what inside of the solution. So if we take a look at some of these here, we can see that like the stuff down here is stuff that you really don't want to have. You prefer to have kind of the green stuff up here, and it talks about kind of like efferent and afferent coupling, so like the number of things that depend on your class and the number of things that your class depends on to function properly. And then this tree map, I think, is also interesting too. That gives you an idea of the cyclomatic complexity of different parts of your namespace. So cyclomatic complexity is a measurement of basically how many different paths there are through a function. So if you have a function that has an if statement in it, then there's two paths through your application, through that function. Either the if is true or the if is false. And if you have a loop, then that adds to it too, or a case statement. Like all of these increase the cyclomatic complexity. And ideally, we want to keep the cyclomatic complexity low, because having it very high means that it's very difficult to test. You can kind of think of the relationship between cyclomatic complexity and unit tests as like you need a unit test for every point of cyclomatic complexity. So if your cyclomatic complexity is 8, you should probably have 8 unit tests covering that function. So you can see that you'd want to keep that relatively low. But this gives you an idea of like, these are some bad places inside of the application here. This is 40 here, so up here it's going to be like over 100 on this chart, which you like. I don't even know how you would possibly maintain a function that had a cyclomatic complexity that high. And then on top of all of this, you can write your own rules as part of this. These are all the kind of rules that exist inside of here, but you can go in and create rules based on your own stuff to give you an idea of, anything in particular inside of your application that you want to query for and fail or pass on. And of course, you can disable any of the built-in rules. So
cool.
I think this is just kind of like a nifty tool for people to play with. I got a license just by being really nice to them and being an MVP, I think. But yeah, it's not something that I would go to like every day probably, unless the job was just to like refactor a really difficult to maintain application. Then I would look at putting it inside of the build tool to make sure that we had that sort of like declining levels of problems as we were going through the application.
Yeah, I've played with NDepend before in much the same scenario that you described, where coming into maintaining a fairly complex application, just needed some tooling to help me get a better understanding of it. And yeah, I found it really useful for that. In the JavaScript world, we have like linters and that kind of thing that give us some ideas of rules that we might want to not break. I kind of think of this as like that on steroids for a .NET app, because it has just such a deeper understanding of the dependencies between various parts of your application. So yeah, super useful, very well done.
Yeah, this is something that maybe we should consider doing an episode on FX cop as well, because that's gone through some re-implementation lately that it might be worth playing with.
Oh, cool. I did not know that.
Yeah. All right. Well, thanks everybody for watching another episode of the Asp.Net Monsters, and we'll talk to you all next week.
Bye.
Bye.